Whoa.
All right. Everybody is here, looks like, and I would like to finish the homework for this. Let's see here, which shouldn't take us, well, we'll see how long it takes us. I don't want to jinx this and say it doesn't take very long. So what we did at the end of last class and what we're doing now is the homework assignment. So it does count for a grade. So make sure you get the answers as we go through them and you actually go in and complete the assignment. Let me get to the ones we haven't done yet. I think that's the one we ended with. And remember, because it was 2 and a 6 in either order, when we drew the first card, 8 cards would satisfy that condition. They're either a 2 or a 6. Once we drew a 2 or a 6, then there's only 4 cards left that satisfy that condition. So if we drew a 2 the first time, then we need a 6 the second time. There's only 4 of those, and vice versa. So that gave us 12. But we talked about that last class, at the end of class. So here we go. Some new stuff. big row, big table of data. Question is, what is the probability that a customer chosen at random, and these are the customers here by region, has been loyal from 3 to 4 years, given that he or she is from the South? So it sounds like conditional probability to me. The probability of 3 to 4 years given from the South. And we know that our formula looks like this, generic formula. Probability of B given A has already occurred is the probability of A and B occurring divided by the probability of A. So this would be the probability of 3 to 4 years and from the South divided by probability of being from the South. So we'll just take this a piece at a time, work our way through it. Now, how many total people in this survey overall?
2008.
Yeah, that's what I think too, Lexi, right here.
Yeah.
So if we added up the row totals here, that adds it to 2008. And if we added up the column totals this way, that would also add up to 2008. That's the total number in the survey. So we need to know, so that's going to be our denominator, I believe. We need to know the probability. What does that 3 to 4 stand for? Customers are loyal. The following table is based on published institute. Loyalty in years at a primary supermarket. So how many years they were loyal to a specific supermarket? So how many people were both loyal 3 to 4 years to a supermarket and from the South?
93.
Very good, Valerie. Very good. It's right here. That's the intersection of the two rows. These are the people that are both from the South and have that 3 to 4 loyalty years. So there's 93 people. We know that's over 2008. We also know that the bottom is going to be over 2008 too, so it'll cancel. Now, what's the probability of being from the South? How many people total from the South?
660.
Very good. You guys got this. They're right there. That's the total from the South. So the probability of being from the South is at 660 divided by the 2008. And like I said, you could actually leave when you're building these, you could leave those denominators off because they cancel anyway. So I get this. And what does that come out to as a decimal?
I got 0.14. Oh, it'd be 0.141. That's what it'd be.
Okay, there we go. Very good. So you just take it a piece at a time. Do the numerator and do the denominator. Don't think too far ahead. Now, this is a similar question. And let you work through it, and then I will do it. And we'll see what we get. Let's see. The question itself is the same thing about regions and supermarkets. The important stuff's down here. What's the probability that customer chosen at random is from the east? That's not even conditional probability, right? That's just a regular probability. All right, this one's as simple as the probability customers chosen being from the east. How many customers are from the east total in the survey?
452,
There you go. And how many people in the survey total?
2008.
All right, so is that what you did? I see 452 divided by 2008.
Yeah, and I got the 0.225.
There we go. See, they weren't asking much. They weren't asking any conditions or anything on it. It just says, what's the probability of being from the east? So that made that problem a lot easier. All right. Here's conditional probability. Being from the east, given that he or she has been loyal 10 to 14 years. So that fits this formula. So let you try that. That'll take a little more work.
I got the second one, the 0.170.
All right, let's check that and see. So we want to know probability of being from the east. This is just from the question itself. Given that loyal 10 to 14 years. So that is probability of 10 to 14 years. And from the east. Times the probability of 10 to 14 years, right? Is that how you set it up, Lexi?
Yes.
All right. I must go
Oh, in 10 to 14 years? Oh, no, I didn't. I did the east. I did the probability of east.
Okay.
Oops, that's my bad.
Probability, let me see. Yeah, 10 to 14 is second, so that's your A.
Yeah, yeah.
That comes on the bottom.
I can do it again with that.
Well, how many people, loyal people, are there 10 to 14 years and from the east?
77.
And yeah, 77.
Very good. And then how many total people from 10 to 14 years?
291. So
So,
now it would be the third answer.
yeah, dropping those 2008s. We'll just do this. And what'd you get for that?
I got the 0.295.
295?
65.
65. Oops, sorry.
This is, Ayana, is that what you got too?
Yeah.
Okay, here we go. All right, some tree diagrams.
Mr. Ritchie,
Yes.
I'm sorry to stop you, but I was just looking and my number 3 is blank. Do you mind telling me what it was? I don't know why it's not there. Or somebody, even if it's not you.
Number 3.
Yes, I'm sorry.
It's okay. That's the questions you see on my screen.
Hmm.
And what was the answer to that? Anybody? 281.
I felt like it was.
I can check.
What was somebody else saying?
No, it was me. I thought it was like the third option, but I did not remember because that's
It
from some
is.
years ago. It is?
Yeah,
Okay.
yeah, it is.
Okay, well, thank you.
Sure. Yeah, sometimes the canvas loads weird on the computer and stuff's blank.
No, it was honestly probably me because I remember texting Lexi because my dogs, I don't know what they had did on Monday, but I had went downstairs for a few minutes and I came back and y'all had passed like 3 questions.
Oh,
She had caught me up, but I forgot that one.
well, we're good now.
Yes, thank
All
y'all.
right, sure.
You're welcome.
All right, this should be pretty easy here. We're talking about flipping a coin 3 times in sequence. Which one of these tree diagrams fits that?
Wait, what was the question again? Sorry.
Scroll up. There it is. So you're going to have to be able to read those tiny letters, H and T.
It's not the first one.
Okay.
It's not the second one.
And that's Mallory, right?
It's
Yeah,
Jalen. It's not the third one.
Jalen, I'm sorry. Let's see, Jalen. Try to catch up with you here. Yeah, it's not this because you can see here, this flipping here, tails and tails. That's not a possibility when you flip a coin, getting a tail or a tail. And this one's a head or a head. So that's how she's
Yeah,
eliminated.
that's what I'm looking at. I'm just looking at the last sequences. It's not that one. It's the last one, I guess.
Yeah, I think so.
I think I agree with you, Jalen. Or one of these last 2.
It's not the very last one because the third row or middle row has 2 heads on it.
Okay. Yeah, I see that now. So it's got to be this one. Because every flip has to have 2 possibilities, heads and tails. Heads and tails, heads and tails. So that makes it that one right there.
That was pretty easy.
Yeah, I like ones like that. All right, only one question left. This is a counting question. Four wires are connected to a circuit board. So here are the 4 connections.
Mr. Ritchie,
Yeah.
my number 12 doesn't look like that.
What does your number 12 look like?
It says how many sequences can contain exactly 4 heads when you flip a coin 6 times.
Does anybody else have that problem? Are you looking at the quiz or the test?
Wait, aren't we on the homework?
Oh, mine says quiz. Well, I thought we were.
Quiz instructions, but like, aren't we on the homework?
Yeah,
Yeah.
that's what it is. Elementary probability homework 1.
Yeah, my 12 looks different.
What does everybody else see? Does anybody else see this one for 12?
Mine looks like yours, Mr. Ritchie.
Yeah, mine does too.
Yeah,
You may
mine
have to
looks
just go
different.
out of it, Ayana, and come back into the quiz. It probably loaded weird.
That's so weird. It's because I've been doing the same questions as y'all.
Yeah, I don't know.
I'll reload it. Hold on.
Yeah, make sure you're going in the homework.
Mine looks like yours too.
Okay.
I just checked.
So my 12 looks different, but my 13 looks like your 12. So do I just have like an extra question or something? Because I promise it's the same thing. Elementary probability homework 1, right?
I believe you, but I don't know what to tell you. It's got to be on your end somewhere.
Okay, well, my 13, I just have an extra question, I guess. So that one is the same. The 12 is just different.
Huh.
Yeah, that's weird, but
Are you using a Apple device?
Yeah, I have a MacBook.
Yeah, the Safari does weird things
Well,
sometimes.
I'm using Google, like Google Chrome. So do I just like, I don't know, I guess I'll just get a lower grade maybe because I'm skipping a question because y'all don't have it. So I
Well,
mean,
just answer the questions that are there. I mean, that other one wouldn't be hard to do.
Yeah.
But if you completely close out Canvas and log back in and before you take it, I would think it would be okay.
Yeah.
But the test may have an extra question. I don't know. This is just the homework.
It's okay.
All right, this one, you're connecting 4 wires to 4 different places on a circuit board. These boxes are those 4 different places. So each wire obviously can only be connected to one. So when you connect to that first connection here, how many wires do you have to choose from to connect to there? You got this wire. That wire. So you have these 4 wires, 4 different colors. And they're going to connect to one each to one of these 4 boxes. So for that first box, how many wires do you have to choose from?
4.
4. Now that you've used one of your wires, it's connected. How many do you have to choose for the next box?
3.
There you go. Now, how many for the next box?
2.
2. And finally, the last box,
1.
1. And remember to count these, all we have to do is multiply. What do we get?
You get 24.
There we go. So we got 24. Now, sorry to cut this class so short, but we got through this and I'm not feeling great today. So I think I need to end the class right here. And you have
Okay.
to take the test and it's available and you can text me if you have any questions.
Okay, thank you. I'm sorry you're not feeling good.
Yeah, thank you.
Father.
I have a bad day every now and then. And I just
Yeah.
think today's one of them. But
I
thank
hope you start feeling better.
Yeah, I'll be
Thank you.
praying for you.
I appreciate it. Thank you
Yeah,
very
you
much.
will.
All right.
Bye.
Bye, everybody.
Better
Yeah.
soon.